All right, so because factoring complex trinomials is such a big skill to learn, I want the main focus for today to be practicing that. So this is going to be just the last topic that we look at today, and it's solving by factoring, because we can use the skills that we learned to factor complex trinomials to solve these. So when we are asked to solve an equation, what that means is we want to find the value of x that makes this equation equal to 0. Okay, so whenever we are solving, you'll notice that we'll always have either a factored form equal to 0 or just really like any form of the quadratic with equals 0 on one side. So typically we would have y equals and then this, but instead of y we have 0. Okay, so if we picture what would be happening on the graph here and what we're actually solving for, if y is 0, that means I'm finding my x-intercepts. Okay, so we can use this in terms of parabolas to find the x-intercepts, or if I'm just asked to solve an equation, that means I just want to determine all values of x that make this equation true. And I say all values of x because if you consider a parabola, typically there are two x-intercepts, or in other words, two values of x that would make this true. Occasionally we have one value, and occasionally we have no values. Now in this case, like if we had no values, we wouldn't have a factored form written for us like this. It would be more so like we would have a standard form, and we'll take a look at how those work in some of the lessons next week. But just kind of in general, you can have two solutions, one solution, or none. Okay, most commonly we'll have two. Occasionally we'll have one. In this lesson, we're not going to have any that have none because I don't know, we're just not going to, unless there's an example where you can't factor. But in the ones I'm showing you now in the video, we're not going to because there's no point in me showing you something that is not factorable. Okay, so what we want to do is we want to let each bracket equal 0. Okay, and then isolate and solve for x. Okay, so we are going to let each bracket equal 0, then isolate and solve for x. And the reason that this works is because when you have anything, like what we have here, we've got this bracket multiplied by this bracket equals 0. And we know in multiplication, this is always true, if you're multiplying anything by 0, your answer is always going to be 0. Okay, so the reason why we do this is because if this first bracket, if we put in a value of x that makes the first bracket equal to 0, then we would have 0 times something. Doesn't matter what that something is, but then the whole thing would be 0. And similarly, if we find an x that when put into this second bracket makes this equal to 0, it doesn't matter what the first bracket's equal to because the whole equation is 0 because you're multiplying by 0. Okay, so what this is going to look like is I will usually just rewrite. I'm just going to rewrite the equation here so you can see what I'm doing, because typically I'll write this directly below when I have my factored form like this. Okay, so I'm going to take this first bracket here and I'm saying x minus 3 is equal to 0. Now, I've already seen some of you do this in the previous lessons when we were finding the x-intercepts, and that is great. Technically, this is the way that you're supposed to show all of it, but we were just using the whole your x lies thing and flipping the sign, which in this case for this bracket does work. Okay, so if we're isolating for x, we want to then add 3 to both sides. So we would just have x equals 3. So in this case, like I said, that first bracket, you can look at it, you've got x minus 3, you know, okay, x is going to be positive 3 then. But we can't rely on that method because for this, it does not work like that, okay? I have a lot of students who, when I taught this course in class this past semester, they relied on just the flipping the sign method, your x is a liar method, and they said, okay, then for this bracket, x is -2. But that is not true. If you sub -2 in here, you are not going to get 0. That would be 3 times -2 is -6, plus 2 is -4, and that is not what we're looking for. Okay, so you need to actually write the bracket, the contents of the bracket, equal to 0, and then isolate. Okay, so this one just has one extra step. So first we want to bring this number to the other side of the equal sign, so we're going to subtract 2 on both sides. We'll have 3x equals -2. We don't want 3x, we want just x, so we're going to divide by 3 here to cancel it out, divide by 3 here, and we have x equals -2/3. In this case, please, please, please do not write this as -0.67 or -0.7 or whatever you want to round it to. Keep it as a fraction. Like if I ask you then to like go and graph it or something, then sure, figure out what it is as a decimal because that's easier. But keep your answer like this so that it's exact. Okay, do not write a decimal answer unless it's like being divided by 2 or 4 or 5, something that will give you a nice terminating decimal place. 3 will never give you a nice decimal place, so just leave it like that, okay? So you can either write your answers like this, you can write x equals 3 and x equals -2/3, or we can write what's called a solution set. And I'm going to just show this over here because I ran out of space. You can write it like this, squiggly bracket, and then you just write both your answers. So like 3, comma, -2/3. This is not a coordinate, it's not a point, because we're using the curly brackets that indicates a set of numbers that are possible. So we call this a solution set. So again, if you've done this course or part of this course before, you might have seen this. Some teachers have different preferences for what they will accept in terms of writing this. Because I'm just asking you to solve the equation, it doesn't actually have anything to do with a parabola right now, we're just solving. So you don't need to write these like the x-intercepts are this and this as coordinates because this is not relating to a parabola right now, it's just an equation. So you can either write x equals 3, x equals -2/3, or you can write it like this solution set, okay? So in this example, we already had a factored form, so it was pretty easy to just let both of the brackets equal 0 and solve for x. But we're going to look and see how we solve an equation if it has x squared and x terms on both sides of the equal sign. Okay, so for example, if I had 8x squared plus 30x minus 48 equals 3x squared minus 4x. Okay, there's a lot going on there, but I have things on both sides of the equal sign. So the first thing I need to do is I need to bring everything to one side. Okay, because I need one side to be equal to 0. And then once I've done that, I can factor and solve. Okay, so with this expression, I'm just gonna actually go ahead and copy this to a different page so I have some more space. But I'm going to show how we do this. So page here. This is the same equation. Okay, so my first step, like I said, is I want to bring everything to one side. I usually do this in one step. You can do it in a few if it's helpful for you to do everything correctly. And it doesn't really matter which side you bring everything to. Typically, I will pick either the left side or the right side, depending on which side will give me a positive x squared term. Okay, it doesn't matter if you do it like the opposite way, you can still, it'll still work. Okay, so what I'm going to do is on the right side here, I want to bring this 3x squared term over, so I need to subtract it from this side. So I always write it directly below that. And then on my left side, I'm writing it directly below the only term that it actually affects. Okay, because we can only add and subtract like terms, that -3x only affects the x squared term. Sorry, the -3x squared. It has nothing to do with the 30x and the 48, so I'm not going to write it near there. Okay, And then, like I said, I like to do everything all in one step. So then the negative 4x I need to bring over as well. So I'm doing the opposite operation. So adding 4x to cancel it out. And then I'm going to write it below my x term here, add 4x, because it only affects that term. Okay, so I'll have 8x squared minus 3x squared gives me 5x squared. 30x plus 4x gives me 34x. The 48 is unchanged, negative 48. And on my right side now I have 0. Okay, so once you have it equal to 0, then you can start factoring. Again, it doesn't matter if you have everything on the other side. The only difference would be that you have, like, they'll be the opposite sign. So in that case, if it was like that, you would have to factor out the negative sign first to be able to factor, like common factor at -1, and then do your complex trinomial factoring. But we will see another example of that later on. Okay, so I've got this now. I want to first check, can I common factor? This is a 5. I can only divide it by 1 or 5, but I can't divide 34 by 5, can't divide 48 by 5 nicely. Anyways, so I'm not going to common factor. I'm just going to go ahead and use either crisscross factoring or decomposition, whatever you prefer. These numbers are kind of big, so I'm going to just use crisscross also because it's just my preferred method. Okay, so I'm going to write my two terms that will give me, multiply to give me 5x squared. So I would have x and 5x. Those two terms would multiply to give me 5x squared. And then I'm going to crisscross and think of two terms that would multiply to give me 48. In this case, there are a lot of options, right? If we start at the beginning, we'd have like 1 and 48, 2 and 24, 3, I think 3 goes into it. 3 and yeah, 16, 4 and 12, 6 and 8, and I think that's it. So you've got a lot of options, but then you can also have like the flipped versions of those. So what I'm going to do is, I should have been writing those as I was saying them. So we've got 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8, and then you'd have like the flipped versions of those as well. I mentioned in the last video, typically the one I always try first is the two that are closest together, especially when my numbers are really big. Like I don't want to start with 1 and 48 because I'm trying to multiply to get 34. And this is fine, 1 times whatever, one of those, but 5 times something, like that's likely not going to work out, and it's going to be a mess. So I'm going to try the two, like I always try the ones that are closest together first, which is 6 and 8. So I will test that out to see what works. I usually am going to see, like, okay, if I'm going to try 6 and 8, I do a quick little, like, okay, should I put 6 here? Should I put 8 here? If I were to put 6 on top, then that would give me 30. This would give me 8. I'm not going to be able to make 34 with that. So I'm going to try flipping it. So I'll put my 8 on top, 6 on the bottom, and then I'm multiplying across my crisscross. Okay, so if I do 5x times 8, that gives me 40x. And then if I do x times 6, that gives me 6x. And I'm trying to see, can I manipulate the signs here to make this equal to positive 34x? My c term there, negative 48, is, well, I just said it's negative. So I know I'm going to have a mix of signs here, one of these positive, one of these negative. So if I have positive 40 minus 6x, that is going to give me positive 34x, which is a match. That is what I want. Okay, so then I'm just going to copy my signs over. So I had a plus 40x, so the plus is on top, it's going to go here. Minus 6x, the minus is on the bottom, it's going to go here. So this is my factored form. If you don't like crisscross factoring, that's totally fine. Use decomposition, you will get the same answer. So now what I have, I've got x plus 8 multiplied by 5x minus 6 is equal to 0. And this is similar now to the first example. It's in factored form, so I need to just let both pieces equal 0. So I'm going to let the first bracket equal 0, x plus 8. and then I'm isolating, so I'm going to bring 8 over. For this one, it's fine if you just want to write like x equals -8. Totally fine by me because we know that little trick that you're just flipping the sign. For the second one, I would suggest at least right now when you're starting out, show what you're doing because you might think, oh, it's not that hard to isolate this in my head. You will make mistakes. I see it all the time. I do it all the time too if I don't just write it down. So just write it. It's also nice for me to be able to see what you're doing in case you get the answer wrong. Okay, so this one's going to be 2 steps. So I'm going to bring 6 over. I now have 5x equals 6. Then I can divide by 5 on both sides. And I have got x equals 6 over 5. In this case, it's fine if you want to write it as a decimal because it's not a bad decimal. It's just 1.2. That's fine. I don't care if you write it like that. And again, you can either write your answers like this, x equals this, x equals this. And honestly, you can either just box it or highlight it, whatever, circle it. Or if you wanted to, you could write it as a solution set, your squiggly brackets, and have -8, 6 over 5, or, well, -8, 1.2. Any of those 3 options are totally fine. Okay, so that's just telling me when I'm asking you to solve like this, you're telling me that x can either be -8 or x can be 1.2, and that would make this expression equal to 0, and that's what we mean by solving a quadratic equation.